are looking for the quiz tomorrow. The first part of this, you do need to add 2 questions. So make a number 8 that says name and inscribed angle. And then also we are going to draw a tangent. There is not a tangent on the picture, so we'll have to draw it on there. There is an inscribed angle on there that we can name. So remember, just kind of a little visual guide here. A radius is halfway across the circle. So looking at our circle, the only segment on there that only goes halfway across from the center to the edge would be TR. Okay. A diameter is the whole way across the circle through the center. That would be QS. So you will have to know this vocabulary. A chord that is not a diameter. A diameter technically is a chord, but any segment that goes across the circle is a chord. If it goes through the center, we call it the diameter. So PS would be a chord that's not the diameter. Okay. To stick with lines, let's go ahead and look at the tangent. Remember, a tangent is a segment or a line or a ray that basically just skims the edge of the circle. So I drew that through Q there. I can put A and B on it so that I can name it. That would be tangent line AB. Okay, a tangent is the one that does not actually enter the circle. It just intersects it at one point. Number 4 says to name a central angle. The word center there is key. Remember, a central angle has its vertex at the center. It's like a piece of pizza. So the only central angle we've got really going on here is QTR. I said only. Actually, RTS would be a central angle as well. It's just a much larger portion of the circle there. But QTR is an example of a central angle. And it is an angle, so it's angle QTR when you write the name of that. Okay. And like I said, RTS technically is also a central angle. Again, let's skip down. So that was our central angle. Let's skip down to the one we added. The inscribed angle is where the vertex is not at the center, it is on the circle. So your inscribed angle in this image that they gave you is QSP. The vertex must be your central letter. We learned that way back probably in October or September even. Okay, so QSP. The last 3, so the first 3 were lines, the next one, and then the one we added were angles. The 3 we've yet to look at, those are all arcs. Remember, a minor arc is just a short arc from one point to another, less than 180. Less than 180 degrees, which means it's less than half the circle. The easiest way just to name one of those is to get 2 points right next to each other. QR is a minor arc. RS is a minor arc. QP. So basically any 2 that are next to each other are most often a minor arc because they're less than halfway around the circle. Let's just go with QR. That arc at the top. Okay. The major circle would be the same 2 letters but going around the long way. It is more than 180 degrees. So if I stick with QR, that's fine, but I have to add a 3rd letter to indicate that I'm not going directly from Q to R, I'm going the long way around. So I could either call that QPR or QSR. It doesn't matter which letter I use, and then you only need one of them. Don't write QPSR. We'll just do P. The third letter in the name indicates we're going the long way around the circle. It is a major arc. And then finally, your semicircle is exactly halfway around the circle. And it is going to start and stop on your diameter. The only diameter he had was QS, so this must start and stop on Q and S. Again, you put a third letter to indicate what direction you're going. Do you want this half of the circle, QPS, or do you want the other half, QRS? Now this is just asking for an example, so it does not matter. QPS or QRS would have worked there. Not all 9 of these terms are on the quiz. 3 of them are on the quiz, but you need to know all 9 of them because you don't know which of the 3 will be on there. And 9 is radius, diameter, chord, central angle, minor arc, major arc, semicircle, inscribed angle, and tangent. Okay. Then we get into area and circumference. You must memorize your area and circumference formulas. I'm not giving those to anyone.
Adam McNeely and Rick Davis, come to the office, please.
Okay. Area is pi r squared. Circumference is pi times d. Right? How do you keep them straight? Area is always squared. When we write area, our answers are inches squared, feet squared. How big of a carpet do you need? 35 square feet. Squared is area. This is area. You need the radius and the diameter on these. Remember, radius is halfway, so this one gave us the radius, but this one gave us the diameter because it gave us the whole thing. So I can do the area here, pi times my radius, 18 squared. You just type that in your calculator. Pi times 18 squared comes out to 1017.9. And then, like I said, technically that would be inches squared. But on this one, because it gave me my diameter, I'm ready to find my diameter. Pi times 25. 78.5. And that's not square, that's just meters. Circumference is a distance. It is asking me to find the others.
I thought you square rooted your area.
Nope, we square rooted our area when we were working backwards.
Okay.
Here we're just using our formula. Okay. So to get circumference, I need to know the diameter, but that's just 18 times 2, or 36. So pi times 36, 113.1 inches. And here, to find area, I need the radius. My radius is going to be 25 divided by 2. Remember, in your calculator, you have to force that to give you a decimal, or change it to a decimal afterwards. I get 12.5. Pi times 12.5 squared. $490.9 meters squared. Okay. On the quiz tomorrow, there's 2 questions. One asks you for area, the other one asks you for circumference. So you don't have to find both. So just pay attention. What does it want? Which formula is that? Do I need R or D? And go from there. There are 2 questions on the quiz that do ask you to work backwards. And that is when they give you the area. The area is 20106. That means 20106 equals pi r squared, because it is the area. We just used some algebra there. I need the radius, so I'm going to divide by pi, and I get 64, I believe, equals r squared. And here is where, let me make sure that was 64. 20106 divided by pi. Yeah, 63,999. Here's where you do the square root, because I'm working from knowing the area backwards to finding my radius, you get that your radius is 8. Okay. Now the question asked for diameter, so why did I find the radius? The only formula I have to work with area is pi r squared. So my only recourse is to find the radius. However, getting the diameter is easy. It's just 2 times that radius. 16. One of your questions on the quiz tomorrow ends there. I just wanted you to find the diameter. The other question on the quiz goes one step further and asks, well, what's the circumference? Well, circumference is pi times d. So if I've found d, I simply do pi times 16. 50.3. Okay, you have to know those 2 formulas. Okay. Number 11. Got a lot going on. But on number 11, your main objective here is to get half circles, because half circles equal 180 degrees. So if you take the information they gave you, MPL, which is this angle right here, at 63 degrees, that means your arc is 63. They told you 90, that means this arc is 90. You are all set. There's a half circle that has to equal 180. There's a half circle that has to equal 180. There's a half circle, but I can't quite use that one yet because I don't have any information on that half. On this half, I have all the information I need. This whole half circle has to equal 180. 90 is spoken for, 63 is spoken for. I am left with 27 degrees. This little guy here must be 27 degrees. There is a slight shortcut. You could have realized this was 90 and just done 90 minus 63. But you would get the same answer in the long run. Okay. Also, then realize that these two are vertical, which means this also has to be 27. So half circles are 180, but then also remember that if you have vertical angles, they are equal to each other. Whatever this arc is, that arc must also be 27, 27 in this case. Now I can handle this half circle. 180 minus 27, 143. There is another way to get that 143. You could have realized that this large angle on the left is congruent to the 2 of these on the right, 90 plus 63. I should have gotten 153. 153. Good thing I checked that. 153. 90 plus 63 is 153. 180 minus 27 is also 153. I just can't subtract, apparently. Now we're ready to answer our questions. JK. JK is the minor arc, 27 degrees, ready to go. NJ, minor arc, 153 degrees, ready to go. JL is a minor arc, but it does encompass 2 of our arcs that are drawn on our circle, the 27 and the 90. So you do have to add the 27 and the 90 and get 117. And now we've got major arcs. You're definitely going to add things together when you're looking at major arcs. KNM, K to N to M. Remember, you have to go in that order. So I can't go KMN. I have to go KNM, which means I'm circling around counterclockwise. K to N to M encompasses the 27, the 153, and the 27. Now, 27 and 153 is 180. So give yourself a break there. 180 plus 27. But individually, 27, 153, 27, 207. MJL is going to be similar. M, then J, then L. So here's M to J, that's half, and then around to L. MJL, everything I just highlighted yellow, you can add 27, 153, 27, and 90. Or it was everything except 63. It's the whole circle except 63. The whole circle, 360, except 63, just subtract it. 297. But if you add 27, 153, 27, and 90, you will get 297. And then JLK, same thing. Kind of running out of different colors of ink here. JLK, here's J, L, then K. So it's going around the entire circle except for this last 27. So again, everything except 360 except the 27, 333. Questions on that? All right. Number 12. This is the same concept except there's algebra involved. Take what they give you, AD, so this is AD right here. We are told 19x minus 49. Now I think on the quiz, instead of giving you arc AD, it gives you angle AED. But angle AED, you guys can read angles, that's the same thing. 19x minus 49. The other one it gives you is CD, which is this one, which is 5x plus 37. Together, those are half a circle. Half circles add up to 180 degrees. So we need to combine them. 19 and 5, 24x. Negative 49 and 37, minus 12. They make a half circle. And remember I had you just kind of highlight, what did I shade in? Half the circle, ready to go. You get 24x is 192. Divide by 24. I believe you get 8. 192 divided by 24. Yes, 8. Now, once again, that's not what they asked for. They asked for CD. CD, according to our question, was 5x plus 37. You're just subbing in. 5 times 8 plus 37 is 77. Be aware they could ask for anything. What if they asked for AB? Well, looking at my circle, AB would have matched CD, so it's still 77. If they asked for BC, then I would have plugged into the 19x minus 49. Okay. Also be aware, the other two situations that we run across with these is if they give you, again, this with this, you would set them equal. Yeah, go ahead. If they give you vertical angles, set those equal. The other thing we ran into, sometimes they give you everything. Maybe there is no like diameter or anything like that, but they give you all the pieces. So if you combine everything, it equals 360. Okay. So 4th period and 7th period moved on. 1st, 3rd, and 5th, we stopped there. But you all, in 4th period, learned how to do arcs. And so those of you who are out on Monday, this is what you missed. The formula for an arc that you will, arc length, that you will also have to have memorized is it's part over the whole. We are looking for the length of the arc over the whole circle, which is its circumference. We have the measure of the arc over the whole circle, which is 360 degrees. Okay. Now I put C here, but remember C is pi times D. So you could just memorize L over pi D equals M over 360. Okay. Where in a circle, if I am trying to find this arc, this is L, this is M, And you know what the diameter is. Diameter, this would be your radius then, but your diameter would be all the way across. So while I've got that sitting right there, let's look at number 14. Notice the shaded part of the arc, or the shaded arc that we want, is this piece. They told us 73 degrees, but we want 360 minus 73, which is going to be 287. This is 287. That's the arc we want. So that's what we're going to use in our formula. Our formula is the length we're looking for is pi times what is my diameter. If my radius is 14.5, my diameter is 29. Pi times 29 equals the measure 287 over 360. You're just subbing everything in. I'm looking for the length. I know the diameter, so pi times 29, or I had to figure it out. I knew the radius. I did have to figure out my arc length, or measure, but we know how to do that, over 360. Then you just cross multiply. So for those of you who were not here, we're solving this the same way we were doing similar triangles. 287 times pi times 29. Which is going to be really big. 26147.5 equals, cross multiply the other way, 360 times L. The reason that number is so big is because I'm getting ready to divide by 360. So divide by 360 and you get 72.6. That was number 14. L equals 72.6. We'll look at another example. This one has the correct arc measure labeled. I don't have my diameter. My diameter is 10, because my radius was 5. So the length I need over pi times 10 is 232 over 360. The part of the circle over the whole circle, the part of the circle over the whole circle. And you can do your cross multiplication all at once. You don't necessarily have to write anything down there. 232 times 10 times pi is 7288.5. You're going to divide by 360. So 7288.5 is 360 L. Divide by 360, you get 20.2. Okay, there's a spot over there for that answer, but that's okay. 20.2. 15 is the same question, it's just making you really work for your arc measure. I know I'm looking for L over pi times PS. PS is the diameter. So pi times 28 equals, I got to figure out the measure over 360. So for ST, this is ST, I got to figure out what that measure is. But that's a half circle. So 180 minus 125, 55 degrees. 55 degrees. 55 times 28 times pi, divide by 360, 13.4. Same thing with RPT. It's L over the circumference, which is pi times 28, because diameter didn't change. I need to figure out what RPT is, but it's over 360. RPT is this much of the circle. Okay. The easiest way to do this would be 360, take away the rest of the circle, the 97 and the 55. 360 minus 97 minus 55, 208. So 208. Pi times 28 times 208 divided by 360, 50.8. Okay. There are 2 questions on the quiz like that. So there were 4 examples, 13, 14, 15, we did 2 different ones. There are 2 questions on the quiz that do that, not 4. Okay. Then you do have 1 applied question here. Merry-go-round. There's my merry-go-round. It has a radius of 18 feet. A passenger gets on a horse located on the edge of the wheel and travels 38 feet. The angle rotation, what is the angle of rotation? It actually wants you to find the degrees in there. So same formula, L over pi times d is the angle over 360. Well, this time I have L. How far did it go? 38 feet. Pi times the diameter is 36, 18 times 2. And then I don't know the angle, that's what they didn't tell me, over 360. The only thing here is to be careful when you're multiplying and dividing, because this would have to be in parentheses. If you just type 360 times 38 divided by pi times 36, it won't register that I'm dividing by both of those. So you might do it one step at a time. 38 times 360 is 13,680. 36 pi is 11309 m. And then now just do that first one, the 13,680 divided by the 13. Do you guys know how to highlight so you don't have to retype all this? So in your calculator, I pulled both of those up. And I don't want to retype 13,680. Just press up and highlight it, hit enter, and it brings it down. Divided by, go get the other one, enter. 120.95, so basically 121. 121 degrees. Then you really don't have to worry about where you rounded because your calculator pulled the entire number down. Okay. Quizzes tomorrow. Use yesterday's review. Sorry, some of you weren't done with that. Use yesterday's review, use today's review. If you owe me work, doing that work would be a great way to review, to get ready for that quiz. Go ahead. Guys, I am recording until I can figure out how to turn it off. So I'll let you know once I get it off. I really don't know how to turn it off.